So next section in chapter 5 is on the sum and difference formulas, and you'll see these on your formula sheet. These are ones that will actually be given to you on your local EOC that you'll take. But just to give you the formulas real quick, the formulas basically say that if you have the sine of one angle plus another, okay, then that's going to be equal to the sine of the first angle times the cosine of the second angle plus the sine of the second angle times the cosine of the first angle. Alright, so that's one of the formulas. And the cool thing is this goes for difference also. So you can put in a minus there. If it's a minus the two angles, then this is going to be a minus between the two terms that you got. Alright, so that's for sine. Now if you have the cosine of the angles, cosine of u plus or minus another angle is going to be the cosine of the first times the cosine of the second plus or minus the sine of each of them. Okay, and again, you don't have to memorize those, but it's good to know them if you want to memorize them. It just makes it quicker than having to plug everything in. So right here, we're going to evaluate a trig function. Find the exact value of cosine 75. Now, of course, we can find an approximate value of that by just typing in the calculator and getting a decimal. But when it says exact value, that means they want it represented as square roots, all right, as some kind of irrational number. So we've got to be able to use our unit circle to find those square values, square root of 3, square root of 2. All right, but 75 isn't one of the angles on our circle that we know an exact value of. So what we've got to do is use the sum and one of the sum or difference formulas and split 75 into two values that we do have on the unit circle. Okay, so an easy one that we can use is 30 and 45, right? We have 30 degrees on a unit circle and we have 45 degrees on our unit circle. So we can say, all right, well, to solve this, we're going to say the cosine of 30 plus 45. All right, and now we can split it up into our sum and difference formula and find the exact values of each of those parts, and then that will give us the exact value for cosine of 75 degrees. So cosine of 30 plus 45. So using our sum formula for cosine, we know that that's cosine of 30 degrees times the cosine of 45 degrees plus the sine of 30 degrees times the sine of 45 degrees. All right, and at that point, all we need to do is look at our unit circle. Oh, sorry, I told you wrong on cosine. One thing is that the signs are different. So the plus and minus do apply for the cosine formula, but the signs are flip-flopped. So if right here it's cosine of the two angles added, then this sign right here is going to be subtract, and vice versa. Okay, for sine, if it's adding on the other part. If it's subtracting, it's subtracting. But for cosine, the signs are opposite each other. So if you're adding two angles, you subtract them. So right here, this shouldn't be a plus. This should be a minus. All right, so now we're going to look at this unit circle and figure out the exact values of each of those. So let's put in our unit circle here so you all can see. All right, so we're looking for each of these values, the cosine of 30, cosine of 45. So let's look at 30 degrees first right here. Remember, cosine is the x-coordinate, so that's going to be square root of 3 over 2. And sine of 30 is 1/2, so we can plug those in. Cosine of 30 is square root of 3 over 2. And sine of 30 is 1/2. And then we can look for cosine of 45. That's going to be the square root of 2 over 2. And sine of 45 is also the square root of 2 over 2. All right, so we plug those values in, and then from there we just multiply and simplify. Right, so let me get this out of the way now. So we got some room. Okay, So now at this point, we can just multiply the two values together on each term. All right, so square root of 3 times square root of 2 is square root of 6. Just top times top, bottom times bottom. On the bottom we got 4. Minus 1/2 times square root of 2 over 2 is square root of 2 over 4. So we got the square root of 6 minus the square root of 2 on the top. And you say, well, that's the square root of 4. No, we can't subtract radicals unless they have the same number underneath the radical. All right, so we can't subtract those. We could subtract it if it was like 3 square root of 2 minus square root of 2. We could subtract those because they have the same number underneath. That would be 2 square root of 2s. You treat it like terms. All right, so 3 of them minus 1 of them would be 2 of them. But can't subtract those. So that's as simple as our answer gets. This is the exact value of this function. You can't reduce those numbers either. The 4 won't reduce with the 6 and 2 because the 6 and 2 are underneath the radical. All right, so let's see if you all can, well, let's do the other one up here real quick. We've got a second example too. Let's go back up. All right, so let's look at this one. This one's a little bit tougher because it's a radian measure. So it's a little bit more difficult to figure out what radians we can use than what degrees. So you essentially got to figure out 1/12. What fractions on our unit circle can we add or subtract to equal 1/12? All right, so once it might be trial and error to figure this out. There's not really a definite way to do it. But 1/12, we know they're going to be very close together. So there should be two angles that are close together if you're going to subtract. Can't really add any of them to get 1/12 because, the smallest one you have is 1/6. So you know you're going to have to subtract. And the ones that we need to subtract right here are pi over 3 and pi over 4. So we're going to say pi over 3 minus pi over 4. And the way we know that works is because pi over 3, when you put it in twelfths, is 4/12. And pi over 4 is 3/12. So 4/12 minus 3/12 is 1/12. All right, so we're going to use the sign difference formula. Let me move this over here to give us more room. So the sign difference formula. So we take, for the sign difference formula on this one, remember we're going to use the same sign right here. So we are going to use a minus between the two things. So sine is going to be sine of pi over 3, the first angle, times the cosine of pi over 4, the second one, minus, and then we take the sine of pi over 4 and the cosine of pi over 3. All right, then you look at your unit circle. I'm not going to take time to bring that thing back up, but you can look at it yourself and see that sine of pi over 3 is square root of 3 over 2. And of course, cosine of pi over 3 is going to be 1/2. And then the cosine of pi over 4 is square root of 2 over 2. And the sine of pi over 4 is square root of 2 over 2. Alright, so we multiply the top, square root of 6 over 4, minus the top here, square root of 2 over 4. So we get square root of 6 minus the square root of 2 over 4. Alright, so a similar answer to the one we got on the last problem. Alright, so go ahead and do the U try at the bottom and we'll go over. Alright, so for this first one, we split up 195 into 45 degrees and 150 degrees. So we're going to use our cosine sum formula. Notice that the signs are different, right? The sign and where we're adding the two things. So for cosine, we use a subtraction between the two terms once we use our formula. So we do the cosine of 45 times cosine of 150 minus sine 45 sine of 150. Then we look at our unit circle to find the values for each of those. We get square root of 2 over 2, negative square root of 3 over 2, square root of 2 over 2, and 1 over 2. Multiply those together and then subtract the numerators since we have a common denominator. Now, this can be your answer, or you might see them write this answer in this way. You might see them take out a negative, and then up top put square root of 6 plus square root of 2 over 4. Okay, they might factor the negative out and just put the negative in front of the fraction. Okay, so that's another way you might see that answer. Basically, they just factored out the negative as a common factor. All right, so then for sine of 5 pi over 12, okay, we want to figure out what are two of our angles on the unit circle that can add up to 5/12 or subtract. Well, we can do 2/12 plus 3/12 to give us 5/12. 2/12, of course, is pi over 6. 3/12 is pi over 4. So we can use pi over 6 and pi over 4 and use a sum formula for the sine. So then when we use our formula, we get sine of pi over 6, cosine pi over 4, plus sine of pi over 4 times cosine of pi over 6. And again, that's just looking at the formula and changing, plugging these angles into the different parts of our formula. All right, then looking at the unit circle, we get a half square root of 2 over 2, square root of 2 over 2, and square root of 3 over 2. Multiply them all together and add the numerators, you get square root of 2 plus square root of 6 over 4. All right, so let's go on and look at another application to these. So this looks a little complicated, but we know how to do this, and I'm gonna walk you through it right here real quick. So we want to find the exact value of sine of u plus v. So we can see we're going to use one of our sum formula for sine, but we're given that sine of u equals 4/5, and cosine of v is negative 12/13. All right, so we're given two parts, right? Remember our formulas for these. You always use the sine of an angle and the sine of the other angle, and the cosine of both angles. So we're given the sine of one of them and the cosine of the other one. But what we've got to do is figure out what's the cosine of u and what's the sine of v. Okay, because we got to know the sine and cosine of both angles. So what we've got to do is use our knowledge of cosine and sine to figure out, using Pythagorean theorem, what the other length of the side is. So let's think about if sine of u is 4 over 5. Sine is opposite. Whoops. Must have hit something. Sorry. Sine is opposite over hypotenuse. Right? So if we know the opposite and hypotenuse, we can find the other angle, right? And it tells us, this is important, this tells us what quadrant we're in. Between 0 and pi over 2. 0 and pi over 2 is this first quadrant up here, right? From 0 to, 90 degrees, or half a pi. So we're in the first quadrant for that one. And for this one, we're between 90 degrees and 180, or pi over 2 radians and pi radians. So we're in the second quadrant for that one. Okay, so I'm going to put that right here. So now we draw our triangle. Okay, you always make your hypotenuse coming out from the center. Okay, so that's my hypotenuse. And then you make your triangle along the x-axis. So we're going to connect down to the x-axis. You always connect it to the x-axis. All right, so the angle, of course, is right here. So opposite that angle is 4, which is the y value. We know sine is y, so that makes sense. And we want to figure out what's the x value right here. So we're going to use Pythagorean theorem. Of course, this is 90, so 5 is our c. So we're going to say x squared plus 4 squared equals 5 squared. That gives us 16 and 25. And when we subtract 16, we get 9. Take the square root, so x is 3. Now, the important part is to know, is it positive or negative 3? Well, because we're in the first quadrant, we know the x coordinate right here. We go along the x-axis this way, it's got to be positive 3. So we're going to use the plus 3, not the minus 3. So for cosine, now we can say, what's the cosine of u? Well, the cosine of u is adjacent 3 over 5. Okay, now let's figure out what's the sine of v. So cosine of v is negative 12/13, right? We're in the second quadrant. So our cosine is adjacent over hypotenuse. So our hypotenuse is 13, so we're going to come out here, 13. Adjacent is 12, so we're going to come out on the x-axis, right? Because cosine's the x-axis. We'll come out here 12. Of course, that's a negative because we're on the negative part of the graph. And then we want to find this value, the y value. So same thing, Pythagorean theorem, y squared plus, you could do 12 squared or negative 12 squared. They're going to give you the same thing. We get 169, right here we get 144. Subtract 144, and you're going to get 25, and then take the square root, and y is 5. So our sine of v is the opposite now, which is 5, over the hypotenuse, which is 13. And again, it could be plus or minus, but we know because we're in the second quadrant, the y value has to be positive 5. So we're not going to use the negative, we're going to use positive 5. All right, so now we know sine u, sine v, cosine u, and cosine v, and we can use those values in our formula to figure out what the sine of u plus sine of v is. So let's plug them in. Sine of u plus sine of v is going to be the sine of one of them. Sine of u, which is, well, we know the sine of u. Let's go ahead and plug it in. So sine of u is 4/5 times the cosine of v, which is negative 12 over 13. And then we're going to add, because our formula tells us to add, and we're going to add the sine of v, 5 over 13, times the cosine of u, which we found was 3/5. All right, so now we multiply the tops and bottoms. So we've got negative 48 over 5 times 13 is 65, plus 15 over 65. And then we add those together, and we get our answer, negative 33 over 65. Just make sure you reduce the fraction if possible. Only thing that goes into 33 is 3 and 11, and neither one of those will go into 65. So our answer is negative 33 over 65. So I know that's pretty complicated, but it's good practice on taking a trig function like sine u equals 4/5 and using that to find cosine. Of course, once you know cosine on this, you can find tangent, cosecant, secant, cotangent. And once you know sine and cosine, you can find all the other ones. So if they ask you to find, the tangent of something, you could do that as long as you know your sine and cosine, because tangent is just sine divided by cosine. All right, so now let's let you guys try one. Okay, so first you want to, of course, figure out the other two trig functions. You're given sine of u and cosine of v. So you want to draw your triangles and solve using Pythagorean theorem for your third side. And make sure you determine, based off the quadrant, whether it should be positive or negative. All right, now I'll go over it. All right, so you can see right here that we had to make sure both of our triangles were in the second quadrant between half a pi and 1/2 pi. So both of them are in the second quadrant, and our hypotenuse was 13 on the first one and 5 on the second one. And then, of course, our sine is a y value, so 5 was the y value going up, and x is what we're trying to find. For the other one, cosine of v, so the negative 4 was our x value going across, and y was the unknown we're trying to find. So when you set up your Pythagorean theorems, we get that x is negative 12. Okay, we use the negative, of course, because it's in the second quadrant, so x has to be negative over there. And then when we get the y value, we get plus and minus 3. So the y is got to be positive in the second quadrant because we're above the x-axis. So now once we know x is negative 12 and y is 3, we can find the other trig function. So cosine of u, going from sine u to cosine of u, cosine is adjacent over hypotenuse. So now we know that adjacent side was negative 12. So we can do negative 12 over 13. And then to find the sine of v, we use the opposite of the hypotenuse. The opposite we found was 3, put it over 5, because 5 was the hypotenuse. All right, so now we know all 4 of the trig functions, sine u, sine v, cosine v, and we can use those to find the cosine of v minus u by using this formula. Cosine of v minus u has got to be the cosine of v times cosine of u plus sine v times sine u. So once we know all the 4 of those values, we can plug them in. Negative 4/5 times negative 12/13 plus 5/13 times 3/5. And we multiply those, we get 48 over 65 plus 15 over 65, which adds up to 63 over 65, which is our answer for the cosine of v minus u. All right, so again, a lot goes into that, I understand, but you guys can do it. I got faith in you. All right, last type of problem we need to work on is being able to solve equations using the law or the difference in sum formulas for sine and cosine. So right here we got to find the solutions for this equation, and what we're going to do is use our sine formula and sum formula and difference formula, obviously, because right here we've got the sine of 2 things added, and right here we've got the sine of 2 things subtracted. So we're going to use both formulas right here in one problem. So we got the sum of sine is going to be the sine of x. For this was the first right here. We're taking this and using our sum formula. So the sine of x times the cosine of pi over 4, right, plus the sine of pi over 4 times the cosine of x. All right, now use the second formula. So we're going to add, right, this is add, so we're going to add, and then we're going to do the second formula for this part. So the difference formula, sine of x times the cosine of pi over 4. We're going to subtract this time. Sine of pi over 4 times the cosine of x, and it's going to equal -1. Running out of room here. A lot to write on this one. All right, so the cool thing right here, though, is that we're going to have two things that will cancel out because we've got positive sine pi over 4 cosine x, and we've got a negative sine pi over 4 cosine x. So on these, a lot of times when you do them, things are going to cancel out. So we can cancel these two out and then take the two things that are left, and they're actually like terms, right? We've got sine x cosine pi over 4 plus sine x cosine pi over 4. So they're the exact same thing, so we can add them together and make two of them. So we can say 2 sine x cosine pi over 4, just like we would if it was x plus x, right? We've got something plus itself, so we can say two of those things. Alright, so now we can solve. Well, we know the cosine of pi over 4 using our unit circle. Cosine of pi over 4 is the square root of 2 over 2. So we've got 2 times sine x times square root of 2 over 2. So I'm going to multiply the 2 and the square root of 2 over 2. Of course, I'll tell my sine x right here. 2 times the square root of 2 over 2. The 2's are going to cancel, and I just leave the square root of 2 times sine x. So now if we are just solving a trig equation like we worked on in section 3, first thing you want to do is isolate the trig function. So we've got to get the sine of whatever, or cosine of whatever, tangent whatever we're solving for, we've got to get that trig function by itself. Alright, so in order to do that, we've got to get rid of the square root of 2. The square root of 2 is multiplying, so we need to divide by the square root of 2. And over here we're going to divide by the square root of 2. So we got the sine of x equals negative 1 over square root of 2, which if we simplified and get the radical at the bottom is negative square root of 2 over 2. Alright, so now we're going to look at our unit circle to figure out when is sine the negative square root of 2 over 2. And that'll give us our x values. So again, the problem tells us to look for when we are between 0 and 2 pi, right? 0 and 2 pi. So we're looking through for the full circle, when is sine negative square root of 2 over 2. So you look at your unit circle and you get the y coordinates of negative square root of 2 over 2 at 5 pi over 4 and at 7 pi over 4. So our answers are 5 pi over 4 and 7 pi over 4. Alright, so you guys try the one down here, we'll go over it, and then you can ask questions if you have any. Again, one thing you want to make sure you do is look for the things that will cancel out, but just plug in your formula, right? Take it one thing at a time. Alright, take the first sum of sines, plug it in, take the difference of sines, plug it in, look and see if you've got something that will cancel, combine like terms, and then just solve the equation like we worked on in section 3. Alright, now this one you've got you got a sum of sines and a difference of sines. It's very similar to the one I just did. So go over it, or go practice it, and then I'll go over it, and we'll be done. Okay, so we plug into our formulas, and we get two things that cancel: sine pi over 3 cosine x and negative sine pi over 3 cosine x cancel. So we're left with 2 sine x cosine pi over 3 equals 1. And we figure out what is the cosine of pi over 3. Look at your unit circle if you need to, and we realize it's a half. So we have 2 times a half, which is going to cancel, and actually sine x equals 1. And then the only time that sine is 1 is at pi over 2. Alright, so that's the answer for this one, just pi over 2, because we're just looking at between 0 and 2 pi. If they wanted all solutions, period, of course you would have to say pi over 2 plus 2 pi n to tell us all the answers, out to infinity. All right, so that's all for this lesson. Let me know if you have questions, and you can use the practice, do the practice problems on the first slide.